Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Asteroids, Trojans, Centaurs, and Comets. In 2007, Richard Firestone and 25 co-authors proposed that impacts or airbursts by one or more pieces of a comet were responsible for the megafaunal extinction and the onset of a cooling period. Some scientists have been trying to determine the astronomical source of this comet to see if it is possible that an associated meteor stream could cause a similar catastrophe in the future. This video examines some of the characteristics of asteroids and comets to get a perspective of the celestial neighborhood of the Earth. During the past decade, evidence has accumulated to support the hypothesis that 12,900 years ago, one or more extraterrestrial impacts caused a cataclysm that resulted in the extinction of the megafauna in North and South America and the start of the Younger Dryas. The Atlantic seaboard is completely covered by Carolina bays, which are the scars left by saturation bombardment of secondary impacts of glaciarized boulders ejected by the impact of a meteorite on the Laurentide ice sheet that covered North America during the Ice Age. The elliptical geometry of the Carolina bays is used to deduce that these geological features originated as conical cavities inclined at about 35 degrees and became shallow elliptical depressions by viscous relaxation. The main cause of the megafaunal extinction and the disappearance of the Clovis culture can be attributed to the saturation bombardment by secondary impacts of glaciarized boulders, which covered an area with a radius of 1,500 kilometers from the impact point and had energies ranging from 13 kilotons of TNT for Carolina bays with a diameter of 200 meters to 3 megatons of TNT for bays with a diameter of 1 kilometer. The saturation bombardment annihilated large animals and humans all the way from the Rocky Mountains to the Atlantic coast. The extinction event and its aftermath are described in greater detail in a separate video. We need to examine our solar system to understand what kind of cosmic object could have caused the Younger Dryas catastrophe. Our solar system has 4 terrestrial planets and 4 gas giant planets. The terrestrial planets are Mercury, Venus, the Earth, and Mars. These planets have rocky surfaces and all have atmospheres except Mercury, which has a thin exosphere made up of atoms blasted off the surface by the solar wind. The gas giants Jupiter, Saturn, Uranus, and Neptune are further away from the Sun. In addition to these 8 planets, there are many other objects in the solar system. The zodiacal cloud is a broad, flat cloud around the Sun that straddles the ecliptic plane. The particle sizes range between 10 and 300 micrometers, most with a mass around 150 micrograms. The zodiacal cloud consists mainly of dust produced by the decay of comets within the inner solar system. The zodiacal cloud, also called the zodiacal light, is best observed at dawn or dusk as a faint, diffuse triangular white glow from sunlight scattered by the interplanetary dust. The terrestrial planets and the gas giants are separated by the asteroid belt, which has millions of asteroids. The outer planets are mostly made of hydrogen and helium with small percentages of methane and ammonia, but the composition of their cores is not well known. Jupiter is the largest planet, and its enormous gravitational pull directly affects the organization of the asteroids. The asteroid belt is also called the main asteroid belt to distinguish it from other asteroid populations in the solar system, such as near-Earth asteroids and Trojan asteroids. The orbits of the asteroids in the asteroid belt are closer to Mars than to Jupiter. Approximately half of the mass of the asteroid belt is contained in the 4 largest asteroids: Ceres, Vesta, Pallas, and Hygeia. Ceres is the largest asteroid with a diameter of 950 kilometers and approximately 1/3 of the mass of all the asteroids combined. Vesta, with a mean diameter of 525 kilometers, is the second most massive asteroid, and it contributes an estimated 9% of the mass of the asteroid belt. The total mass of the asteroid belt is estimated to be about 4% of the mass of Earth's moon. NASA's Dawn spacecraft was launched in 2007. It entered orbit around Vesta on July 16, 2011, and became the first spacecraft to orbit a body in the region between Mars and Jupiter. Dawn left Vesta on September 5, 2012, en route to Ceres, and it entered Ceres orbit on March 6, 2015. Dawn's mission concluded on November 1, 2018, when it ran out of fuel, but it will remain in orbit around Ceres for at least 50 years. Ceres is officially recognized as a dwarf planet because it orbits a star, which is our Sun, and it is massive enough for its gravity to compress it into a spherical shape, but it does not qualify as a full-fledged planet because it has not cleared all the material around its orbit. Asteroids are not evenly distributed within their disk structure. In 1866, Daniel Kirkwood noticed gaps that are associated with the orbital resonances with Jupiter. For example, there are almost no asteroids with semi-major axes near 2.5 astronomical units, which would make 3 orbits for each orbit of Jupiter, called a 3-to-1 orbital resonance. Other orbital resonances correspond to orbital periods whose lengths are simple fractions of Jupiter's orbit. The weaker resonances lead to a depletion of asteroids, while spikes in the histogram are often due to asteroid families related by composition. The Kirkwood gaps in the asteroid belt have an analog in the rings of Saturn. The large gap between A and B rings is called the Cassini division. A particle in the Cassini division would go around Saturn twice for every time the moon Mimas goes around once. This is a 2-to-1 resonance orbit. A particle in the Cassini division is pulled by Mimas' gravity at the same place in its orbit every time that Mimas passes by. The gravitational tugs add up until the particle is pulled out of the Cassini division. The gravitational effect of the Saturn-Mimas system on Saturn's ring is similar to the gravitational effect of the Sun-Jupiter system on the asteroid belt. The Lagrange points are named after Joseph Louis Lagrange, who in 1772 published an essay on the three-body problem, where he described 5 points of gravitational equilibrium. Of the 5 Lagrange points, L1, L2, and L3 are unstable, but points L4 and L5, which are at the apex of 2 equilateral triangles between the 2 large bodies, are stable. Objects at the L4 and L5 points maintain their relative position because the gravitational forces of the 2 large bodies combined with the centrifugal force of the co-orbiting small bodies are balanced. Trojan asteroids orbit the Sun at the same distance as Jupiter in the L4 and L5 Lagrange points, roughly 60 degrees ahead or 60 degrees behind Jupiter. The Jupiter Trojans are divided into 2 groups: the Greek camp in front of Jupiter and the Trojan camp trailing behind Jupiter. Hilda asteroids are in a 3-to-2 resonance with Jupiter. This enables them to travel in a somewhat triangular orbit up to the distance of Jupiter without being scattered. All asteroids orbit the Sun. Their relative movement around the Lagrange points is called libration. The total number of Jupiter Trojans larger than 1 kilometer in diameter is believed to be about 1 million, approximately equal to the number of asteroids larger than 1 kilometer in the asteroid belt. Centaur asteroids orbit the Sun between Jupiter and Neptune and cross the orbits of one or more of the giant planets. The Centaurs lie generally outside the Jupiter Trojans and inwards of the Kuiper belt. They are called Centaurs because they resemble asteroids in size but are similar to comets in composition. This duality is reminiscent of the half-human, half-horse creatures of Greek mythology. Centaurs have unstable orbits due to gravitational interactions, and they have dynamic lifetimes of only a few million years. The Kuiper belt is beyond the orbit of Neptune. It is similar to the asteroid belt, but it is far larger, approximately 20 times as wide and up to 200 times more massive. The Kuiper belt is a disk-like region of the solar system beyond the orbit of Neptune that contains many small bodies made largely of ice that may become short-period comets that take less than 200 years to complete an orbit around the Sun. At one time, Pluto was considered the 9th planet of the solar system, but in 2006, the International Astronomical Union demoted it to the status of dwarf planet after the discovery of more dwarf planets in the Kuiper belt. Most Kuiper belt objects are composed largely of frozen compounds like methane, ammonia, and water. The Kuiper belt has 4 officially recognized dwarf planets: Pluto, Haumea, Makemake, and Eris. Haumea is one of the fastest rotating large objects in our solar system. Its fast spin is responsible for its egg shape. Professor Mike Brown from Caltech has discovered many trans-Neptunian objects using the Palomar Observatory telescope. Professor Brown's discoveries are responsible for demoting Pluto to dwarf planet status. He teaches the science of the solar system in a free online course available through Coursera.org. I took this course in 2014 and I highly recommend it to anyone who seriously wants to learn about the solar system. The Oort cloud is found beyond the Kuiper belt. It is an extended shell of icy objects that exist in the outermost reaches of the solar system. The Oort cloud is roughly spherical, and it is thought to be the origin of most of the long-period comets that take more than 200 years to complete an orbit around the Sun. Comets are composed of rock, dust, water ice, and frozen gases such as carbon dioxide, methane, and ammonia. Space probes like the Rosetta mission have provided much information about the constitution of comets and the conditions that existed during the formation of the solar system. When comets approach the Sun in their highly elliptical orbits, the heat of the Sun vaporizes some of the comet's material, releasing dust particles trapped in the ice. Solar radiation pressure and solar wind blow away gas and dust from the comet's nucleus, forming a tail that can extend for many kilometers. Comet Shoemaker-Levy 9 was discovered in 1993 after it had been captured by Jupiter and was orbiting the planet. Calculations showed that it broke apart in July 1992 during a previous closer approach to Jupiter. The pieces of the comet collided with Jupiter in July 1994, creating huge brown spots in the atmosphere, some of which were bigger than the Earth. These first-hand observations raised awareness of the danger that cosmic collisions pose for the Earth. A meteor shower is the result of an interaction between the Earth's atmosphere and streams of debris from a comet. The torids are an annual meteor shower associated with the comet Encke. Encke and the torids are believed to be remnants of a much larger comet that disintegrated over the past 20,000 to 30,000 years. This is the largest meteor stream in the inner solar system, and it takes several weeks for the Earth to pass through it. Some scientists have suggested that the Tunguska event in Siberia and the Younger Dryas event may have been caused by impacts of comet fragments from this meteor stream. NASA has established a Planetary Defense Coordination Office to address the Near-Earth Object Impact Hazard. The office sponsors studies of technologies and techniques for deflecting asteroids that are on a collision course with the Earth. What is next? It has become very clear that 12,900 years ago, an extraterrestrial impact caused a worldwide catastrophe that set back human civilization. We live in a cosmic shooting gallery, and we have limited means for detecting and diverting comets or asteroids. I wonder whether the nations that have the capability to reach space would join their resources to protect mankind from an impending cosmic disaster, or whether inaction by divisive nationalistic politics would doom our species to extinction. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.